All right, so Algebra 1, lesson 4.7, okay? We are looking at solving our linear equations by using a graph. Okay, so up until now, we have been solving our equations algebraically, right? So you would do like 3x plus 5 equals 20, right? We would solve it algebraically. We would subtract the 5, divide by 3 using our inverse operations. In 4.7 though, we're going to look to solve these equations by using a graph. So, and we can find this on page 250. Okay, our general steps to solve are first write it so that it's equal to 0. Right, that's what that means. We're putting everything on one side of the equal sign. Okay, then you're going to write the related function. So y equals ax plus b. What that means is replace your 0 with a y. And then finally, you're going to graph that equation. Okay? So then you're going to look for your solutions because you simply replace the y or the 0 with a y. Your solutions or solution for this is the x-intercept, meaning where your graph crosses the x-axis. And the reason for that is because you were solving when it equaled 0. You let y equal 0. That happens when you're looking for your x-intercept. Okay, since that's what y equals 0. All right. So let's see how we do this then, okay? So we want to solve the equation negative x minus 3 equals 0.5x. We're going to solve it algebraically. And then we're going to check using our graph. All right, so to solve algebraically, that means we're taking our equation and we are isolating x. Okay, so with what we're given, we have x on both sides. So I want to put the x's together. So since the right-hand side of our equation has just a term with x, I'm going to move the x's to the right. So it's negative x, so I need to add x to both sides. So negative x plus x cancels. That's how you get negative 3 on the left. And then 0.5x plus x would be 1.5x. Then you need single x by itself, so I'm going to divide both sides by 1.5. So I get x equals negative 2. And if you look at your notes that I uploaded, okay, I printed it incorrectly right here. Okay, that should not be negative 1/2 or negative half x. This should be negative 1.5x. So just know that's a mistake. All right. So I get that x should be negative 2. Okay, so I'm going to check this graphically. So what that means is I have to take my equation and get it equal to 0. So I'm going to now move the half x to the other side. So I subtract half x. So I get negative 1.5x minus 3 equals 0. Then I replace the 0 with a y, and I get y equals negative 1.5x minus 3. Now this is what I have to graph. So we just learned how to graph using slope and intercept. Okay, so when I look at this equation, my y-intercept is negative 3. So I go down 3. And then the slope is negative 1.5, which is negative 3 over 2 as a fraction. So that means I'm going 3 in the negative. So I could go down 3, 1, 2, 3. Then I would go right 2. So 1, 2 to here. Or you could have said I'm going to go up 3, so 1, 2, 3. And then I still need negative, so I'm going to go left 2. 1, 2. Okay, then I can connect my points. Put arrows on it. And we said the solutions are where the graph crosses the x-axis. So the horizontal is my x-axis here. This is where it's crossing. Happens to cross at negative 2. So that's what I got algebraically. I checked it graphically. I get the same answer. So we can conclude that the solution is x equals negative 2. Okay? All right. One more. We want to solve 5/2 x minus 1 equals 9/2 x. We're going to solve using our graph, and then we are going to just check algebraically. You can, once you get a value, you can just plug it in for x and see if it works. Okay, so the first thing here is I have to put everything on one side. So I'm going to, this is positive 9 over 2, I'm going to subtract 9 over 2x from both sides to put my x's together. So 5 over 2 minus 9 over 2 is negative 4 over 2. And negative 4 over 2 is negative 2x minus 1 equals 0. Then you replace your 0 with a y. So I get y equals negative 2x minus 1. So then I need to graph this. Here is my x-axis. Here's my y-axis. Okay, then 1, 2, 3, 4, 5, 6. All right, So looking at our equation, our slope is -2 and our y-intercept is -1. So we're going to graph -1 first as the y-intercept. So here we are. Then we're going to use our slope. That's -2 over 1. So we can go down and right to get negative. We're going to go down to 1, 2 over 1. Or you could go up and to the left to get negative. So up 2 over 1. Okay? Then use a straight edge and connect your points. And the solution happens to be where the graph crosses the x-axis. So it crosses right here, and that looks like it's at x equals -1/2. In order to check, all I need to do is to take this value and plug it in for x. You could also solve algebraically. Okay, so I'm going to put the check over here. We have 5 over 2x minus 1 equals 9 over 2x. We get graphically that x should equal -1/2. I'm going to show you 2 ways to check this. Okay, one is to just solve algebraically. So I'm going to move the x's over to one side. I get -1 equals 2x, and then I'm going to divide by 2. So I get x is -1/2. Okay? Or you can substitute in. We're going to get 5 over 2x minus 1 equals 9 over 2x. But we're saying x is -1/2. So 5 over 2 times -1/2 minus 1. Does that equal 9 over 2 times -1/2? And 5 over 2 times -1 over 2 is -5 over 4 minus 1. And 9 over 2 times -1 over 2 would be -9 over 4. So we would get -5/4 minus 4/4, because I need there to be fractions with the same denominator. And -5 over 4 minus 4 over 4 would be -9 over 4, which does in fact equal -9 over 4. So -1/2 is our solution. Okay? And that is lesson 4.7. So you should have a chapter 4 quiz. Okay, make sure you get that done. No test yet. We have one more lesson for chapter 4.